All right, so let's get back to the simple cases and talk about this next section, which might be the first one if we do not have a monitoring information available. The report might actually start then after the general information with this section here, and it's a bit similar what I try to summarize here on active session history level than what you see from real-time SQL monitoring. So there's some overlap and some things that are mentioned again. So do not be confused that you, for instance, see the minimum and maximum DOP again. The reason is simply, as I pointed out, this section very easily could be missing, and then it's quite helpful to get some information based on active session history than not having it at all. So again, you, for instance, see here the instance count. So you would see here the number of instances that were involved. So in this case here, you would see an instance count of 2. So which tells you from active session history point of view, more than one instance were here involved. Then you get an information about the session ID that was this execution, the main execution was done in this session. Either if it's serial execution, then of course this is the session that did actually the execution, but if it's parallel execution, then the session ID here is the so-called query coordinator session, and also you get the information about on which instance this session was. In case of cross-instance parallel execution, the query coordinator could be on a different node than the parallel execution servers that actually did then the work that was supposed to be done by the parallel execution servers. We have the user ID here, which should correspond to this username. Typically here, the reason why I do not resolve here the username is that you could have custom repositories like the SASH environment, and in such cases querying the user information from DBA users wouldn't be the correct approach, because SASH might have collected user IDs that have nothing to do with the local user IDs. So that's the reason why I simply leave it here with the user ID and do not show the username. Then in active session history, there is this top level SQL ID information that might be helpful in case of recursive activities. So if you, for instance, had a PL SQL block that executes SQL in turn, then you have already a level of recursion, because the top level SQL ID would then here refer to this PL SQL block rather than the SQL ID that gets executed. In this case here, we see that the SQL ID and the top level SQL ID are the same. And if we had multiple levels of recursion, then this top level SQL ID would actually refer, as the name suggests, to the top level of the recursion. So you can't necessarily tell from the top level SQL ID and the SQL ID whether this is actually recursive activity or not. But just to give you this information here, because it's part of the active session history, I provide here this top level SQL ID. Then you get an information about the first sample and last sample that is that could be found in the active session history for this particular execution. And of course, typically this should be somehow related to the duration. You can see here some minor difference between the real-time SQL monitoring information and information that active session history extracted from active session history. This sometimes is related to rounding issues, because I round here the timestamps of the sample times in active session history to dates, and then sometimes you get here this difference between 1 and 2 seconds depending on this rounding, but it shouldn't typically be be more than that. Of course, as I said, the database time could be different, so you might have idle time in between, and therefore I have this additional information, this duration active, and this basically means the duration total, and this active and total is something that you will see multiple times in these sections, therefore is probably important to explain it. This duration total here is typically based on calculating first sample to last sample. In this particular case here, it's not calculated on first sample to last sample, but it's based on the SQL exec start and the last sample. So possibly you might have the case that the SQL execution started at some point and one or two samples might be missing from active session history. That happens sometimes. So in this case you can see here this here, which could, by the way, again be caused on some rounding issues, that this slight difference between SQL exec start, which is actually a date, and the sample time, which is a timestamp, the difference could also be caused by this rounding that I mentioned. So this duration total here is basically last sample minus SQL exec start, and therefore I arrive here at this 72 seconds. The duration active is basically the information how many samples in active session history were found with activity. So you see here this minor difference that only 70 samples were found with activity, sample points, because with parallel execution you could have more than one sample per sample point. So 70 sample points of active session history information was found for this particular execution. If there are, typically these two shouldn't be too different, they should be quite similar. If they are different, and in this case of course active duration should be less than the total duration. If you have such a case where the active duration is less than the total duration and there is a significant gap between these two values, then this indicates that there was some application think time, idle time in between. And that's the reason why I differentiate here between total and active, to give you an idea about this possible case of significant idle time, application think time in between. Then from active session history I cannot tell whether the status, whether the execution is still running or not, because there is no true information about whether this execution is done or not. If you, for instance, think about an application that fetched a number of rows from the result set and then has some application think time, and then possibly might fetch further rows some time later, this is simply something I cannot tell from active session history. You can tell this from the real-time SQL monitoring, because in this case the status is still executing because the cursor is still open. The status would be executing in this case, although there is no current activity of this cursor. But from active session history I can only tell whether there was recent activity or not, and that's simply the approach to show inactive or active as status. If there's no recent activity for this execution, then the status will be shown as inactive, and if there is recent activity, then it will be shown as active. Then you get an information about the total sample count found. You can see here that with the active duration of 70 seconds and 186 samples, we obviously have parallel execution with some thing more than one, on average more than one session active, and out of these total 186 samples, there were 132 samples that were about CPU activity, and this means this profile here is 71% CPU activity, which more or less is what you should also see here. Quite often this is pretty close. The instrumented CPU time and the sampled CPU time is typically pretty close. Here we can see we have 2 minutes and 12 seconds approximately sampled, and we have 2 minutes 17 instrumented CPU time, so there is a 5 seconds difference. That's pretty close. It's not always that close, but typically it should be in the same ballpark. Then I have here a number of sections that you won't see from real-time SQL monitoring or from other reports, but I find them very important for getting a good understanding of a parallel execution profile, because it tells you about the number of samples that you have spent in sending and receiving of data. Parallel execution plans typically have to shuffle around data several times during execution, so data will be redistributed between the parallel execution server sets. And the point is that you can easily spend significant amount of time in these redistributions, and this is a typical parallel execution overhead that you will not have with serial execution, because with serial execution there's no point in redistributing data, and hence I find that information quite helpful to understand, to get an idea about the overhead. We can see here, for example, that which is a bit an extreme case, because that's the way I engineered this example here. But you can see here that we have 97 samples spent in this send and receive part, and out of these 186 total samples, this means that more than 50% of the execution time was actually spent in sending and receiving of the data, which is a significant overhead. For non-extreme cases, you would typically will still see here between 20 and 40% of time spent in sending and receiving if you have multiple of those so-called DFOs. So if you have several of these redistributions, it's not uncommon to see between 20 and 40% of the execution time spent in these redistributions, at least according to the sampling, which is of course not precise, but it gives you an idea. And even 20 or 25% of your overall execution time spent on only sending and receiving of data tells you that parallel execution comes with significant overhead. And the same I repeat for the CPU part. So typically sending and receiving of data is CPU intensive, but in case of cross-instance parallel execution, you might even have network activity, because the data must then send and received via these private interconnect links between the instances. So here I give you an idea about the CPU level of activity, sending and receiving of data. So in this case we have 96 samples, and this means that out of these 132 total CPU samples, in this case actually 73% of the overall CPU activity was spent on sending and receiving, which again, as I say, is an extreme case here. It's an engineered case that you typically shouldn't see that extreme values for CPU time spent on sending and receiving. But again, as I said, since most of the time of send and receiving is spent on CPU, this 20 to 40% that I mentioned for typical executions, it's not unlikely to see here again something between 20 and 40% of the CPU overall CPU time spent on the redistribution of data. Then here is this repetition of the degree, minimum and maximum degree from version 11.2.2 on. This is also something that Xplan Ash can extract from active session history information, so the actual degree will then be part of this undocumented PX flags column of active session history, and this is where Explain-Ash extracts this information from. And again, this minimum and maximum is just to give an idea whether this is an execution plan that was using different degrees or whether the same degree was used, therefore the same like the real-time signal monitoring information with this minimum and maximum degree. Then we see here the worker count and the so-called unique worker count. What's the difference between these two sections? The PX worker count gives you just an idea about the number of different processee names that active session history found in the samples. So we can go here to this section about the parallel execution servers, and if you look here, you see here that these process names, there are actually only 6 different unique names. So you see here P000 to P005. So these 6 servers were found in the active session history information, but the point of this second part here, where I talk about the unique count, this means that some of these parallel execution servers got reused in in another DFO tree. So as I explained in some of my other tutorials, when one DFO tree of a parallel execution server of a parallel plan, when a DFO tree of a parallel plan starts, then it acquires parallel execution servers and it deallocates them when the DFO tree ends. And typically, if you have a scenario where one DFO tree starts after the other, then the same parallel execution servers that just got deallocated by the end of the previous DFO tree will simply be reallocated for the next DFO tree. So the same parallel execution server names, if you want to say so, will be reused, but they will get some unique serial number information by getting reinitialized, and by querying this information, Explain-Ash here can differentiate between the servers. In total it was just 6 different servers that were used, but 3 of them were basically re-initialized in another DFO tree, and therefore we end up here with a unique count of 9. So if you have a difference between worker count and unique count, then this is typically caused by this reusage, this re-initialization of these parallel execution servers when multiple DFO trees are involved. So that's the meaning of this unique count and this non-unique count, to give you an idea about this reusage of parallel execution servers. Then for the to give you an idea about the distribution of work, I provide here such averages, and this means average active sessions, this AS, average AS active sessions, average active sessions total, and average active sessions active. Again, this differentiation between total and active is about the total average active sessions is across all sample points from first sample to last sample. So if there was no activity for certain sample points, then this will be reflected here in this average as non-activity. So typically the average active sessions total and average active sessions active will be quite similar. But if there is again a significant difference between these total and active average active sessions, then this means that there were significant number of sample points where no activity at all was recorded in active session history. So there was some kind of idle time. And as I will show in another example, and I've already shown this in the introduction of the Explain-Ash version 4, if you have recursive activity with different SQL identifiers, then this could also be an reason why you see a lower average than you might expect, because these average active sessions here are only about those samples that could be related to this particular monitored execution. And if you have samples that are related to recursive activity with different SQL identifiers, as I've outlined in the initial part of this tutorial, then this will show up in different sections of the output. So to come back to these two values here, the total is about all activity, including sample points where there's no activity, and this is the average active sessions only for those sample points where actually at least one sample was found. And typically these two are quite similar. If there's no significant idle time, these should be more or less the same. And if there is idle time, then this active value will be greater than this total value. Then, since averages typically suck, so you know that you have to be very careful with averages, therefore I provide here also the middle value. So you can tell from a significant difference between the average and the middle value that you will have to check the details that will follow further down the script output. You will have to check how the actual activity level on let's say on a more granular level looked like, because if these two are very different, then this is very likely that there are huge differences, huge variations in activity. Not necessarily, not always this is really indicated by these two values, but I just started to add these median middle values in most of the parts where I also have averages, because sometimes it's helpful to give you an idea about how careful you have to be with this average value. One thing that you can already tell from this average value, at least here, is that if this average value is far below the degree, so we have here a degree of 3 and, well, 2.6 and 2.7 average active sessions is not too far below that. But if this was, for instance, a degree of 16 and you had here an average active sessions of only 3 or 4 or 5, then having this lower average value is a clear indicator that there is a problem with the work distribution. So this is what I talk in detail about in these other tutorials with parallel execution skew. So if not all of the parallel execution servers are working all of the time, and the work is typically not evenly distributed among these parallel execution servers. So this average here, if it's significantly below what you expect in terms of the degree, then it's very likely that you have a problem with the work distribution. Another possible explanation, and therefore these two values are important, another possible explanation of an average that is different from what you expect is that you might have here different degrees. So if, for example, you have a part of your execution plan operates at a degree of 2 and another part at a degree of 16, then of course the overall average might be influenced by this lower degree and might give you an overall average that is far lower than this 16 that you possibly might have expected. And to give you a little bit more information for this average part, you even get this maximum and minimum. So this is the maximum active session average active sessions maximum that was found in all samples. So here we had a maximum of 5 and a minimum of 1. In this case, since I only look for active sample points, the minimum possible here is 1, not 0. because okay, 0, I thought it's more helpful to give you an idea for those samples where actual activity was, to show you the minimum rather than showing you possibly that there were sample points where no activity was, which would then be the minimum value 0. And then I added the standard deviation, but I think since this is not necessarily a normal distribution in these values here, it's probably not really helpful, but I'm not that into this statistics stuff, so I added it, but it possibly should be ignored, this standard deviation stuff. Then finally we have the maximum PGA information across, summarized across all sessions for parallel execution. If there are multiple sessions, this is the maximum found across all the sessions during the execution, which is available from version 11.2 on, I think, in the active session history. The PGA is also recorded, and this is the maximum value here, to give you an idea what was the maximum PGA allocation of this execution. Similar, the maximum temp allocation of this execution will also be shown here. And then finally we have the module, which is available from the active session history, action, machine information. These are just the corresponding fields from active session history, and likewise there are these no yes indicators in the recent releases of active session history. I think they were also added in 11.2, I think, and I just for completeness show them here in terms of percentages of the total samples, how many of these samples had an yes flag in these corresponding columns. So you can see here how much of these samples, how many of these samples then showed a yes flag. So maybe sometimes this can be quite interesting. For example, it gives you an idea how much time on PL SQL execution was spent in this execution. If the same information would be available from real-time SQL monitoring in this PL SQL Java time, database time. In this case, this is instrumented time, so this is a rather precise information here. Whether in contrast, this here PL SQL execution and Java execution are samples, and quite often these two, if you have both available, you will notice that this these two, the instrumented database time spent on PL SQL and Java, is not really that close. At least in my experience, these two are not that close to each other. The percentages here shown in from active session history are quite often different from what the real-time SQL monitoring shows, but nevertheless it gives you an idea, a ballpark figure, potentially how much time this execution spent in PL SQL or Java execution, and maybe even on sequence activity and so on. Yeah, so that is what you get from these flags, from this summary of this statement execution. For cross-instance parallel execution, there will be an additional section, as I've already mentioned, on instance level. So you more or less get the same activity like you get for the summary on instance level summarized, with a bit of additional information, like when did this instance for the first time take part in this execution. So when was this instance for the first time found in the active session history, and of course then the remaining information is pretty similar. We can see here again that this is a case where we have not the same level of activity, which is not we have not the same level of activity, which is very obvious in this case, because I used a degree of 3, and if I have to use a degree of 3 across 2 instances, then very likely one of the 2 instances will have to work more than the other. As we can see here, on average more than two sessions were active on one instance, and on average only one session was active on the other instance. Well, yeah, that's more or less the same here that I've already described from the upper part. One thing that you get here that you do not get from the global summary is a graphical representation about the activity pattern. So, for example, you might have here a case where in between some instances were not really doing anything about this execution here, were not really had no active parallel execution servers involved in the execution, and therefore sometimes this time active graph can be helpful for understanding the execution profile. So this is basically a graphical representation that this is the start of corresponds to the first sample, and this is the last sample, and this is indicating then the activity in between. So basically, were there any samples found for these sample points in between or not? So we can see here there were obviously some sample points where the second instance was not really doing anything, whereas the first instance was doing something all the time. And the remaining flags are again the same that you see from the overall global summary here in the previous section.